So the operation is very simple. You have three terminals: gate, source, and drain. And it's a unipolar device. As you know, the conductivity depends only on purely on electrons or purely on holes. So the noise is less. The device is going to be an excellent device under highly noisy environment, because the noise offered by the device is going to be very, very less. So you have it is just a MOSFET is just a resistance. It is just like you add a third terminal, which allows the value of resistance to be modified between source and drain. Between source and drain, you have a channel, and through channel, the electrons are going to flow. And you can control how much electrons you are going to flow using the voltage available at the gate. So it is just like a variable resistor. MOSFET is a variable resistance, and this variable things come from the gate source voltage VGS. So VGS is going to control the current flow in the MOSFET. If the power is less than that to deliver to a load, power gain results. And in junction FET, a reverse bias PN is control the resistance between the source and drain terminals. So this is an P channel between source and drain. You have yeah, it is a N channel, so it's an N channel MOSFET. And if you have a P channel, you will have a P type here and N type here. And N type, the majority carries electrons, so it is much faster when you compare with P channel, because generally you would associate with the term called mobility. So mobility is the ability of the charge carriers to move under an applied electric field. So when you see the value of mobility for electron and hole, the electron possesses a larger mobility when compared to holes. So generally we prefer N-channel MOSFET for all our application, where speed is the major criteria. So the depletion region formed between, you have an PN junction, right? So depletion region completely depends on what voltage I'm going to apply between the gate and the source and drain terminals. So it is going to alter the cross section area, thereby modulating. See, the word modulation means something is varying. Because of a gate voltage, what I am going to apply in the device, I am going to change the area of the channel, or I'm going to change the conductivity of the channel, or I'm going to change the resistance of channel. All are going to be the one and the same. And gate is always reverse bias, so the current flowing through the gate is virtually zero. We in the equivalent circuit of MOSFET, if you see at the gate side, we present open circuit saying that it projects an infinite resistance, and at the output side you present the current source, where we say it is going to be gm into vgs. Okay, and you have a drain current which is flowing at the output of your device. So I'm not going in depth into the basics of MOSFET, because it is almost the basics should be known to you. So we'll see what additional thing we require from MOSFET for high frequency operation. So power gain of MOSFET is very, very large when compared to BJT. And if you want to completely turn off the MOSFET, if you supply a very large negative reverse bias to the gate, then you can completely turn off MOSFET. In that case, you can even operate MOSFET as a switch. So binary logic 0 and 1. So 0 is going to be the cutoff condition, and 1 is going to be the saturation condition. So that can also be either you can use MOSFET as an amplifier, or you can use MOSFET as a high speed switch.